Welcome to the lectures on problem solving and programming in C. This is lecture 5 and the title of the lecture is Algorithm for Some Basic Problems. In the last few classes, we have seen what are structured programming construct, how algorithms are developed or built using these basic programming constructs and combining them using stacking and nesting. And in the last lecture, we have seen how to draw flowcharts, which are diagrammatic representations for algorithms. In this lecture, we will take some more computational problems, more basic computational problems, and then try to develop algorithms for them. So in this lecture, we will focus on these small basic computational problems, computing the maximum of three numbers, sum of first 10 natural numbers, factorial of a number, printing different triangle patterns. So, okay, let us move on to one by one. What is maximum of three numbers? So, if input will be three numbers, let us assume that they are integers, and output will be, we need to display the maximum of all those three numbers. So we usually represent, as we need three numbers, we will use data holders or variables to represent these three numbers, A, B, and C. So we will store data in these variables A, B, and C. Variables are basically data holders. Data holders. So what will be the sample in some sample input outputs? So if the input is 10, 20, 30, the output should be 30. If the input is 55, 45, 25, output should be 55. If the input is 120, 150, minus 30, output should be 150. If the input is minus 20, minus 20, minus 30, output should be minus 20. So this is sample input output specification, sample input and output. Let us try to develop an algorithm for this. So usually, so what in the last class we have seen an algorithm to compute maximum two numbers. Suppose if I have A, if I compare A and B, if A greater than or equal to B, then or else what can happen is A less than B. These are the two possibilities between the relationship between A and B. If A greater than B, then we can discard B. The maximum can be among A and C. So that is why we compare A. If A greater than or equal to B, C, then implies A is max. Okay. Else, if A less than C, implies C is max. And C is the maximum. Because if A greater than B, it means if A greater than B, it means that A is the maximum among A and B. Okay. Then to decide the maximum number of between A, B, C, we just need to compare A with C. So if A greater than or equal to C, then A is the maximum. Otherwise, if A less than C, C is the maximum. Because B is already less than equal to A. So B will not contribute to the maximum number. Otherwise, if this condition is false, what does it mean? It is A less than B. So implies now we need to compare B. If B greater than or equal to C, implies B is the max. B is max. Okay. If B less than C, then C is max. So there is one selection statement, if else here, if else. Okay. And then inside if here, one else here. If here, one else here. Okay. So there is an if inside if. This is a nested selection statement. This is basically nested selection statement. Yeah. So let us try to develop an algorithm for this. So what is the name of the algorithm? This is how you develop algorithms, write algorithms. What will be the name of the algorithm? Algorithm. So max 3 What will be the input? Input will be three integer numbers, numbers A, comma B and C. What will be the output? Output, the maximum of, need to display maximum of A, comma B and C. So there will be begin statement, begin, and end here. This is my empty algorithm. Now we need to read, I need to input A, need to read ABC values, right? Input A, input B, input C, input C. Then first thing is on first level, I need to compare A and B, right? If A greater than or equal to B, then what then what we need to do, we need to compare A with C, right? If A greater than or equal to C, then output A, because A is the maximum number. Else if else means A greater than C is equal to false, it means A less than C. We need to compare again here. Else means by default it means that A less than C. Then output C. And if we need more space, so let us remove this end block here. Right. So else this if will also have else, right? Else this will also have else means if A less than B, A less than B means B is the maximum among A and B. So then we need to compare B and C. A if B greater than or equal to C, then output B, else output C. So this have and if, sorry, this if have and if, and this if will also have and if. And then final statement end. This is an algorithm. We see here, this is called indentation. What I have written? I have written this entire if block little bit indented because this is the nested if statement. In if statement inside if. So by looking at this, I know that this entire if else block is inside this if. And similarly, this entire if else block is inside else block. That is why it is indented. You see here, this statement is indented deeper with a deeper nesting because this is inside this if statement. This is called indentation. This is the algorithm, proper algorithm. Let us see the algorithm in proper format. So this is the algorithm. So input A, input B, input C. If A greater than B, then we have another if statement, nested if statement to compare A and C. Based on the comparison, if A greater than C is true, then output A, otherwise output C. Else, if you are coming else part means A greater than B is false, by default false. So then B is the maximum among A and B. So we are comparing B and C. B greater than equal to C, output B. Else, C is the maximum, output C. This is algorithm. This is the formal algorithm. Let us trace with an example. So let us take some example. Let us say A equal to 10, B equal to 20, C equal to 30. So now if A greater than B is false, so you will come here. So B greater than equal to C is also false because 20 greater than equal to C is false. So you will output here C. The output C will display 30. Let us take some other example. Minus 20, minus 30, minus 50. Okay. So if A greater than equal to B, true. A greater than minus 20 is greater than minus 30, right? So you will come here. Is A greater than equal to C? Yes. Minus 20 is greater than minus 50. So you will output A. Minus 20 will be output like this. So this algorithm, you can trace different examples like this. So this algorithm actually compute the maximum number of three integer numbers, and then it displays the maximum number. Okay, there is no restriction on the type of the data. I mean, you can use the same algorithm to display for integers also, for decimal numbers also. In algorithm there is no data type, what kind of data you're using. But when it comes to programming languages, um, data type may be crucial or important. Okay, then that we will see while writing converting this algorithm to a program in the next class, next lecture. Let us go to the next problem. So next problem is sum of the first 10 natural numbers. What is sum of the first 10 natural numbers? Let us see. Suppose if n equal to 1, sum of first 10 natural number is n, 1. If n equal to 2, it will be 1 plus 2 is equal to 3. If n equal to 5, it will be 1 plus 2 plus 3 plus 4 plus 5 is equal to, this is 5, 15. Like this. So for n equal to 10, it will be 55. Like this. So in mathematics, we have a formula. Sum of the first 10 natural number is n into n plus 1 by 2. Okay. If you use this formula, we can easily compute the sum of n natural numbers using arithmetic expressions. But that is not the intention. We want to learn. We want to compute this using repetitive statements like this. Repetitive statement like this. We will compute to add one by one number by one number until we sum up first 10 natural numbers. That's where we use the repetitive statement to solve this problem. Let us see how to develop an algorithm for this. So algorithm. So algorithm. Sum n natural numbers. Input is n greater than or equal to 1. Output sum of first n natural numbers. Okay. So we will have a begin statement here, and then you will have end statement here. Okay, this is an empty algorithm. So every time when you are writing an algorithm, first write an empty algorithm and add statements here. Okay. If you don't know how long the algorithm will go, maybe you can hold the end statement. So what I need input n, right? Input n. So since we are expecting n greater than or equal to 1, we need to do an input validation. In the previous case, we don't bother if A, B, C are positive or negative. That is why we are not making any input validation. But in this case, we are looking for a positive integer number greater than or equal to 1. N should be greater than or equal to 1. If n is less than or equal to 0, we should say that it is invalid input and stop the algorithm. So if n less than or equal to 0, then output invalid input. Stop the algorithm. And if, okay, by chance if user enters my negative number or 0, the algorithm will display invalid input and algorithm is stopped. Otherwise, we will come here. So what we need to do, we need to compute the sum of first 10 natural numbers. So by default value will be 0, 0. 0 will add 1, I will add 2 like that. So what are the numbers for which numbers we want to do? We want to repeat for I equal to 1, 2, and 2. Okay. How do you sum up? Sum will be sum equal to sum plus I. Initially sum is 0, sum plus I will be 1 and 1 will be stored in I. Next I will be 2 and sum will be 1 plus 2, 3 like that. We repeat this statement for all values of I 1 to n, then eventually end for and output sum. Okay, this is the algorithm. Let us trace with an example. So let's say n equal to 5. So let us say n equal to -1. If minus n less than equal to 0, so it will display invalid input and stop. So this case is invalid case. Suppose if n equal to 5, so what happens? N less than equal to 0 is false. So we will come here, sum equal to 0. So some value will be, sum is 0 initially. So for I equal to 1 to n do. So it means that for I values ranging from 1 to 1, 2, 3, 4 and so on n, we need to repeat this statement sum equal to sum plus I. So what is the current value of sum? 0. 0 is equal to sum equal to 0 plus 1. I in first value of I equal to 1, right? So it will be 0 plus 1, which is equal to 1. Sum will be 1. And then next I becomes 2. So sum equal to sum plus 1. So sum is 1. 1 plus 2 is equal to 3. Then next I becomes 3. So 3 plus 3 equal to 6. Then 6 plus 4 equal to 10. Then 10 plus 5 equal to 15. So like this. So for I n is equal to 5. So we will stop for y values of 1, 2, 3, 4, and 5. The sum is computed. So final value of sum will be 15. So output will be 15. 15 will be out. Like this, it will compute the sum of first 10 natural numbers. What you need to observe is you have used the repetitive statement here, and we have used a selection statement to validate the input, and then we have used a repetitive statement to compute the sum of the first n natural numbers. Also, we have used nested statements, nesting also. This is the sequence statement inside repetition. This is sequence statement inside selection, and this is also indentation. Okay, we have used the indentation. Let us see this example in a proper algorithm. So this is the algorithm. Sum of natural numbers. Input is a positive integer n greater than 0, and then output is sum of the first 10 natural numbers. Input n, if n less than or equal to 0, or invalid input and stop. Then whatever I have written in the whiteboard, I have typed neatly in this board so that you can see it clearly. To tell you, in algorithms we don't really care about case whether the capital letters, small letters. You see here it is a capital sum here. Yes, it is a small sum. So both are same. Both should be treated as same. In algorithms, we don't really care about uppercase, lowercase. Everything will be treated as equal. But when you convert this algorithm to programming language, programming languages are usually case sensitive. Then in that case, you need to make sure that every token, the sum is spelled in a consistent case. Suppose if S is capital, so we should consistently spell S as capital. That we will see these kind of things we will see when you are converting this algorithm to programming language in the coming lecture. So let us move on to the next problem. So this is factorial of a number. Factorial of a number. What is the factorial of a number? Factorial of a number is, so 0 factorial is 1. 1 factorial is 1. These are the base cases. 2 factorial is 1 into 2 is equal to 2. 3 factorial is 1 into 2 into 3 is equal to 6. Similarly, 5 factorial is 1 into 2 into 3 into 4 into 5, which is 120. So similarly, see these are 10 factorial. If you see 10 factorial, it will be 3, 6. 288. The factorial value will be growing very fast because we are multiplying with a bigger number every time. So let us try to develop this. The logic is very similar to what we had done previously for some of us 10 natural numbers. Only thing is, instead of addition, we are using a multiplication. Let us see the algorithm. Let us try to change the algorithm. So I will modify this, duplicate this. Okay. So this is the algorithm. What is the, where is the change? I will mark the change with yellow color. So this will be, since we are expecting 0 is also valid, you will have a less than here, less than symbol here. Because, so this will be factorial, here, this will be n greater than or equal to 0, or n greater than or equal to 0, then this will be factorial, n factorial, we need to display n factorial. So this, if n less than or equal to 0, then output invalid input. So it will be factorial, fact equal to 1, factorial equal to 1. Then, because if you are multiplying with 0, everything becomes 0. That's why we have to start with 1. So this will be factorial equal to fact equal to fact multiplied by I. Okay, and output fact. This is the algorithm. So very similar to that. Only difference is we are multiplying. We are initial starting value will be 1, because since we are multiplying. If this is 0, everything will become 0. Because 0 is multiplied by anything is 0. That is why we start with 1. So factorial equal to factorial star I. So initially factorial will be 1. So 1 star 1 is equal to 1. Next 1 star 2 equal to 2. 1 star 3. Like this, everything will be multiplied like this. Eventually, when you compute for the n value, the factorial data holder will contain the factorial of n, number n. Let us see the formal algorithm for this. This is the formal algorithm. You see here, the input is expected integer, positive integer number n greater than or equal to 0. The output is factorial of n. So if n less than 0, invalid input stop. If factorial equal to 1, for I equal to 1 to n, do fact equal to fact star I and output fact. Suppose what happens if n is equal to 0? If n is equal to 0, then n less than 0 will be false. You will come here. The factorial will be set to 1. And then since n is 0, you will not, none of the statements in the for loop will be executed. So what happens is you will straight away come to this statement and output factorial as 1, which factorial which has a value 1. So this algorithm will also work for 0 factorial, 1 factorial, and so on. Okay. Of course, when you're translating this algorithm to programming language, lot of things we need to worry about. So because when you're talking about numbers in mathematically there is no limitation. But when you come to programming languages, there is a limitation. Each data has each data holder or a variable has a fixed size. So when you're trying to compute a factorial for a bigger number, there will be a number overflow because you cannot store in an integer variable, for example, you cannot store beyond a certain value. If you are trying to compute factorial of a bigger number, what happens is overflow will occur and you will not see the correct factorial. It will see some random arbitrary number. Let us see. Yeah, let's move on to the next problem. So these are the patterns, 4 patterns. These patterns, so we need to print, these are 4 different problems. This is not one problem, this is 4 different problems, A, B, C, D. So in one problem, you want to display this pattern, this triangle pattern. What is this triangle pattern? The starting star, there is a single star and then 2 double stars, 3 stars, 4 stars, 5 stars, like this. If n is equal to 5, we should display this number, this pattern. So if n equal to in B, and if n equal to 5, we should display this pattern. In C, if n equal to 5, you should display this pattern. The number of rows, basically you need to read the number of rows you want to print the pattern and then display accordingly. What is the difference between this and this? Difference between this and this is, here stars are coming at the beginning, but there is a lot of gap in here in the pattern C, there is a lot of spaces. There is spaces here, then followed by stars. Okay. So you need to worry, you need to print spaces first and then followed by star. Otherwise, the pattern will not become like this. Let us see example. We will see one example this and one example this. Others can be easily done. Yes. So let us try to print this pattern. This pattern I'm trying to print. Sorry. So this is my pattern, first pattern. This is my this is normal first triangle pattern A. Okay. So let us try to build another. What is this? What did you observe? If n equal to 5, it has 5 rows. We need to display 5 rows. Okay. So row 1, row 2, row 3, row 4, row equal to 5. So in row 1, how many stars are there? 1 star. In row 2, how many stars are there? 2 stars. In row, how many stars are there? 3 stars. In like this, if row equal to I stars should be displayed. Similarly, if row equal to n stars should be displayed. So you remember, you can't display I stars or n star in one go. What you can do is you can only display constant number of stars. Let's say 1 star, 2 star, 3 stars using the output statement. You cannot display a variable number of stars in with a single output statement. That is why we have to use a repetitive statement. Let us see. So I've just write the logic here, and then we will we will develop the actual algorithm here. Yes. So algorithm pattern A, then input is n greater than or equal to 1, output is pattern, display pattern. Okay, what we will do is let us try to type the algorithm here only. So this will be pattern A, triangle pattern A, triangle pattern A. So it will be greater than 0, a number positive integer number, then display the pattern A pattern, right? If n less than or equal to 0, it will be output invalid input because the triangle pattern will have at least one row. So, right? So for I equal to n, so we know that we need to display. So we need to display how many rows? N rows, right? So that's why for I equal to 1, 1, 2, and do end for. So this is a for loop. So we need to, this for loop is for rows, n rows. And for each row I, we need to display I star. So that's why we should have another repeated statement, j equal to 1 to I 2 and for. So output star, single star. Okay. Output star. Then, so after every row, there should be a new line because it is a new line. Output new line. So this is the algorithm, simple algorithm. Okay. So this first for loop is for number of rows. Then second for loop is basically to display the corresponding stars. For I, if the I value is 1, we need to display one star. If I value is 2, we need to display 2 star. If I value is 3, we need to display 3 star. If I value is I, we need to display I stars. That is why for j equal to 1 to I, output star. So this loop will run for I times where I value is varying from 1 to n. So this end of this, and for after printing one row, we need to display the new line. So how to display a new line in programming languages is we'll learn in the coming lecture. So this is algorithms. Once we have an algorithm, translating it to a programming language is very easy. So that will be discussed in the coming lectures. Let us see the next pattern. Next pattern, pattern 2 is this. So first, if n equal to 5, we need to display 5 stars, and then 4 stars, and then 3 stars, and then 2 stars, and then 1 star. So what happens is it will be n minus 0, this is n minus 1, n minus 2, n minus 3, and n minus 4. This is how number of stars are reducing by 1. So if I is for a fixed value of I, what happens is n minus I plus 1, n minus I, n minus I minus 1, n minus I minus 1. Because if I equal to 1, you should start by I equal to 1, you should get n. Okay. So if I substitute I value n, you should get 1. So that's why this is the expression. So what happens is we need to display this pattern B. Pattern B. Let us say for I equal to 1 to n, for j equal to 1 to n minus I minus 1. I minus 1. No, it's n minus I minus 1, right? N minus I minus 1 output star. That's it. So instead earlier we are doing for I times, but here what we need to do, we need to do n minus I minus 1 times, right? N minus I minus 1 times, right? This is pattern B. Let us see pattern C. Pattern C. What is the pattern C? Pattern C is this. Pattern C is this. So what we need to do? So if you take this, so there will be space, 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 star. There will be space, 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 star, star. There will be space, space, star, star, star. There will be space, star, 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 and then star, 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 star. So see, we cannot print right away star here. So we need to print spaces because it is printing usually display happens row by row. So row by row and column by column. Initial the contents will be displayed here and then gradually grow like this. To display stars in this pattern, we should nicely display spaces followed by stars. So that is why. How many spaces are there? So earlier, so I equal to 1, 2, 3, 4, and so on I value, how many, and so on n value. How many spaces? How many stars? Spaces. Initially 4 stars. 4 star means how many? N minus 1. N minus 1 stars. Okay. How many stars? 1 star. Then if n equal to 2, n minus 2 star spaces and 2 stars. 3, n minus 3 spaces, 3 stars. N minus 4 spaces, 4 stars. And if I equal to I, n minus I spaces and I star. And n equal to n minus n, so 0 spaces and n star. So we need to have a logic to display spaces and star. Let us try to print the algorithm. So there are n rows, right? And so what you need to do? First let us display number of spaces. How many spaces we are displaying? N minus I. n minus I. When I value is there, n minus I spaces are displayed. So n minus I output space is okay. And then followed by immediately, we need to, the spaces should be followed by stars. How many stars? I star. I star. Star. So this is, and followed by new line. This is the logic. This is the logic to display. We are using nested for loops, and then one repetition followed by the another repetition. This is to display the spaces, required spaces, and this is for displaying the required star. And followed by, after each row, we will display the new line. Yes. Let us see the last pattern. Last pattern D. Pattern D. This is what happens initially. When equal to 5, display like this: 5 stars and space 4 star, and then double space 3 star, and then triple space 2 star, and 4 space one single star, like this. So initially number of what is n I equal to 1, 2, 3, and so on I, and so on n. So number of spaces, and stars. Number of spaces are how many? Number of spaces 0, initially 0, and these are n stars. Now for 2, 1 space, n minus 1 star, and so on for 3, 2 spaces and n minus 2 stars. And for I, it is actually, if you see 1, if it is 0, so I will be I minus 1 spaces followed by n minus I stars. For n, it will be n minus 1 spaces and 1 star. Sorry, n minus I, it will be n minus I plus 1. N minus I plus 1. Or I minus 1. This is I minus 1. N minus I minus 1. N minus I minus 1. Because if it is putting n minus 1, if n minus 1, it will be 0. 0. Let us look at it. If I equal to 1, it should be n spaces. So n minus of I is 1. 1 minus 1, 0. Correct. Oh, yeah, right. So n minus I minus 1 spaces. Stars. I minus 1 spaces and n minus I minus 1 stars. So if you substitute n, n minus n minus 1, it will be 1 star, right? So let us display this. What is the answer? I minus 1 spaces followed by n minus I minus 1 stars. Yes. I minus 1 spaces and then n minus of I minus 1 stars. Stars, that's it. This is a pattern D. Okay. The only thing is very similar. These patterns are very similar in nature. In one case where stars are starting in the beginning, but in the other case where the spaces followed by stars, we have to nicely display spaces before the stars so that the pattern comes in that format. Because in a row we cannot display directly fifth character. We can only display 4 characters followed by fifth character. Okay, so if you are If you want to display nothing to be visible in the first four characters, we have to display with the spaces. Okay, these are the. Let us move on to the next. So that is it for this. Um, that's it for this lecture. Okay, we will in the next lecture we will see how to translate these algorithms to programming language like C. Okay, thank you.